Hi, this is Tony Tomasi with NVIDIA, here to give you a little background on a video we put out recently about high frame rate gaming and the benefits to latency, smoothness, and animation. Before we dive into this in too much depth, let's first understand a couple of the fundamental concepts, that being frame rate, which is typically your GPU, and the display rate, or hertz, which is typically your monitor's ability to refresh the screen. The animation that you see here is a demonstration of the monitor and the GPU's rates. The topmost graph is showing the rate at which the monitor is refreshing the screen, which is measured in hertz. On the bottom, you're seeing the graph of the GPU's render rate, or frame rate. While it might average 60 frames per second, some frames are faster and some frames are slower, and they don't perfectly align. For high frame rate gaming, you want both of these to be as high as possible. Before we dive into our topics in detail, one clarification I should make is we've made a simplification. We've made the assumption that our GPU rate, frame rate, and our display rate, hertz, are the same thing. While this doesn't typically happen in the real world, this is a simplification we've made to help with the fundamental concepts and understanding. So one of the first topics we want to talk about is animation smoothness. One of the things you'll notice that is a great difference between a 60 frame per second and a 240 frame per second game is the smoothness of the animation. And that's because in each case, the rates of the animation updates are happening at different frequencies. 60 frame updates happen once every 60th of a second, which means that as an animation is stepping through, it only has 60 times every second to update its position, which means the steps are larger. At the 240 frame rate, the updates are happening 4 times as frequently, once every 240th times per second, which means that the size of the animation steps are smaller, which makes the animation feel much smoother. Taking a look at this top and bottom, you can see that 60 frame and 240 frame rate video have a very different feel in terms of smoothness. The 60 frame rate video has much larger animation steps, making it feel much less smooth than the 240 frame per second video. Next up is ghosting. Ghosting is that property we've all experienced, and you see this kind of faint blur that looks like it's trailing an object in motion. That's actually a side effect or a property of our typical modern flat panel displays because they have an update rate. Looking at our bouncing ball animation, you can see that the step size is fairly large, which means that smear behind the object is fairly pronounced. If we look at the animation now at 240 Hz, you can see the step size is much smaller, which makes the ghosting much less pronounced and therefore much less distracting. Looking at this in-game in CSGO, our character is moving from right to left. At 60 Hz, you can see the animation steps are fairly large, so the ghosting is fairly pronounced. On the right-hand side, you can see the character moving at 240 frames per second, and the steps are much smaller, so the ghosting much less pronounced and therefore much less distracting. To understand our next topic, tearing, it's important to understand another concept, which is VSync. VSync is the synchronization, or lack of, between the display and the GPU. In the VSync on scenario, the display and the GPU are locked, which means the GPU only presents completed frames on the display. In the VSync off scenario, there's no waiting, which means the display is going to continue updating and it's going to grab the frame at whatever state the GPU happens to have it in, which could be sometimes partial frames, and then present it. That partial frame appears on your screen as a tear. Why would you accept tearing? Well, one of the advantages of VSync off is that the GPU can render as fast as it possibly can, which can make the game feel much more responsive. We've made some simplifications here today around VSync for understanding. We'll get into more complex topics like G-Sync and variable refresh rate at a later date. As you can see here in the animation, the lack of synchronization between the GPU and the display causes tearing. The GPU is required to present an incomplete frame. The size of that tear that you see there is determined by the animation step. At lower frame rates, those steps are fairly large, so tearing can be quite pronounced. At higher frame rates, the steps are much more frequent, so they're smaller, so the tears are much less pronounced and therefore less distracting. Looking at tears in CSGO, we can see here as we zoom in on the vertical brown tower, the tears on the top are much smaller than the tears at the bottom at 60 Hz because the animation steps are much more frequent and therefore the tearing much less pronounced at 240 Hz. Our final topic is system latency, which is a bit more complicated. System latency is typically known as that mouse click to muzzle flash or that motion to photon latency. It is not network latency, which is typically how your computer communicates over the internet to a back-end game server, sometimes referred to as lag. Taking a look at our game pipeline, we have a 60 frames per second example. And again, for simplification, we've decided to set the GPU rate and the CPU rate to be the same. So in this case, they're both at 60 frames per second. That means the blue bar here, the CPU, takes 16 milliseconds at 60 frames per second to do its work. It then hands off that frame to the GPU, which also takes 16 milliseconds at 60 frames per second to do its work. The gray bar that you see there is the amount of time it actually takes the display to update and show you that frame. At 240 frames per second, everything speeds up. Our CPU work, our GPU work, and our display work are all roughly 4 times as fast, so at 240 frames per second, your system latency is 1/4 the time. Using a single frame as an example, we have a fast system here on the top and a slower system on the bottom. They're both doing the same work, which is to render and produce a single frame. The fast system is producing CPU work, GPU work, and display work sooner than that slower system doing the same work. The difference between those two is the difference in overall system latency, which is felt as reduced input delay, which is mouse click to muzzle flash or motion to photon. Okay, to bring this all home, let's take a look at an example of system latency in CSGO. At the top, we have a fast system running at 240 frames per second, and at the bottom, a 60 frame per second system. They're both receiving updates from the network at the same time, but the faster system processes that work faster, resulting in lower latency, and the slower system takes longer. Denotated here by this vertical bar, the difference between a 240 frame per second system and a 60 frame per second system is quite pronounced. That difference is the difference in system latency, which lets you, as the player, react faster. So we've explained some of the fundamental concepts, but why is this important? Why does high frame rate matter? What we have here is a chart that plots the correlation between high frame rate and success in a first-person shooter. In this case, what we've done is measured kill-death ratios in battle royale games like Fortnite and PUBG, and as you can see, there's a correlation between higher frame rates and higher kill-death ratios. If you're interested in the study, please check out the link below. We hope you found our video on high frame rate gaming informative. Please leave your thoughts in our comments below, and be sure to check out our slow-mo high frame rate video. Thanks for watching.